We are going to work on inequalities, looking at one variable inequalities. Before we begin, I want to go over the vocabulary that goes with trying to figure out our symbols. So let me move my screen over here. And let's go, and we're going to write down 5 symbols. Let me break this up into 5 spots. All right, I'm going to have these symbols right here. All right, so now get those written down, and now let's write down the phrases that we can use. We're going to make this an ongoing list to find the phrases that can be used when they're dealing with inequalities. One thing on the far right, we know this is equal. Okay, when something is equal, we'll just put that one there. Let's start over here on the left. What is this symbol right here? This symbol is greater than. Another way we can write it is more than. See, and the one that is opposite that is the one over here in this third column. This is the less than symbol. People get confused between less than and greater than. I want you to take your hands and I want you to try and make this symbol. Which hand can you make this symbol with? If you take your right hand and try and make that arrow, does it look like what I just highlighted? No, it's opposite, isn't it? So turn it the other way, or not turn it the other way, but use the other hand. Use your left hand. You can make that symbol with your left hand. Left hand starts with L, less starts with L. That's one way you can remember that this is the less than. If you can make that symbol with your left hand, left starts with L, less than starts with L. Another word that you can use for instead of less than is fewer than. Now, what is this symbol right here in the second one? This is greater than. Or equal to. And the one over here to the left is less than or equal to. Okay, so let me try and separate. Let's see. A few other phrases that we could have. There's going to be one that is no more than. No more than will be less than or equal to. No more than. And then no less than. We'll go in this one. Will be no less than means greater than or equal to. We have phrases like at least. At least will be greater than or equal to. You'll see that a lot on your test. And at most is less than or equal to. Let's see. No less than, got that one. At least, at most, no more than. I'm trying to look through my list here. Can you think of other phrases that might go in here? Keep this list going, and as we go through some of these, we'll add more to them. So let's come back over here to our assignment today. Take a few minutes, and I want you to try and do the first 6. Try and make your best guess, and then let's come back and see how you did. Number 1 says at most. Remember we said over here, at most, right here, is less than or equal to. At most is less than or equal to, because. So before I say because, let's do this. At most, less than or equal to. So this is letter D. The at is treated as an opposite. So instead of like most, when you see that at, it's like saying the opposite. So that's why it goes less than. But at most, you're getting $5. So you're getting less than or equal to. Number 2 says X is less than 5. You should have gotten B for that. Number 3, no less than. No less than. You're going to do no less than 5 push-ups. You're going to do 5 push-ups or more. So it's going to be C, greater than or equal to. Let me make sure. Did we put no less than over here? Sure did. Number 4, X is more than 5. That means X is greater than 5. You're going to have A goes here. So let's see, more than. I'm pretty sure we put more than. We sure did. X does not exceed 5. Okay, let's think about this. If you do not exceed, what does exceed mean? Exceed means go over. So if you do not exceed 5, you do not go over 5, you're doing less than or equal to. So you should have D. So less than or equal to, let's go over here. Less than or equal to, and let's put in there, does not exceed. Now this one's kind of tricky because the other one you could have is exceeds. If you exceed the speed limit, what are you doing? If you exceed the speed limit, you are going over the speed limit. So when you exceed, it is greater than, not equal to, just greater than, because you're going over the speed limit. All right, let's go back right here, and it says X is fewer than 5. X is fewer than 5. That means less than, fewer than, less than 5. So it can't equal 5. So did we put fewer than? We sure did. All right, so now let's go to the next part. We're going to talk about how to write an inequality and how to graph it. Another part that we need to talk about in our notes is this. When we are going to be graphing on a number line, okay, let me make these lines. Actually, let me move this up and then you guys can still use the same ones. I'm just going to make it a little bit easier to see. So well, didn't spread it out very well, did I? 1, 2, 3, 4. And right here we had greater than or equal to, less than or equal to, and equal to. Okay. Whenever you have something that has greater than or less than, you're going to use an open circle when you graph. And you'll see what I mean in a minute. And you use an open circle because it's not equal to. So open circle. When it is greater than or equal to, or less than or equal to, when the equal to bar is in there, you're going to use a closed circle. Closed circle. Now, that's also going to be true when you just have equal to. Well, that makes sense. Now, when you are trying to shade, if it is greater than, you're going to shade to the right. Greater than, shade to the right. Less than, you shade to the left. Oh, I was going to make an arrow. Less than or equal to, shade to the left. Now, an equal to, you just put a, why did I put circle? It should be closed circle. Oh, here we go. On equal to, you're just going to have the closed circle. So I'll make my examples here. So you can write those down, and then this number line. I'll give you a second to write that down as I'm trying to get these written down. We're doing all of them at 2, so I'm just going to draw a little line and mark my 2 to where you can see. Make sure you have this written down so you can follow along and have them in your notes. You're going to need them for your tests. Okay, if you need more time, you can pause it. But here's what I'm trying to say. When it is x, let's go over here to the right. When it is x is equal to, if x is equal to 2, all you're doing is put a closed dot at 2 because it is just equal to that number, and the only solution is that number. Now, if I go back over here to the right, like we're over here to this part, it says x is greater than 2. It says to use an open circle, so we're going to do an open circle, and greater than means to shade to the right. Okay, so this means that anything to be a solution is anything in the shaded area. The 2 is not, it's not equal to 2, so that's not a solution, but the solution, a solution is anything in the shaded area. If they ask you, is 5 a solution? And if it's in the shaded area, then that is true. The next one says x is greater than or equal to 2. So you're going to use a closed circle and shade to the right. Everything that is in the shaded area and 2, those are solutions. That's because they're equal to it. Less than means open circle, shade to the left. Again, everything that is a solution is only in the shaded area. 2 is not a solution, okay, because it's not colored in. It's an open circle. Open circle means it is not part of the solution. If it was less than or equal to means a closed dot, and we shade to the left. That means all of the things in the shaded area and 2, all of those are solutions. Take that and make sure, pause the video and make sure you have all that written down. And then we're going to go over the next part for our notes. So you should have this all written down. So let's look over here to what we're supposed to do now. Now it says we're going to write the inequality and we're going to graph it. And then we're going to tell if something is a solution. This says x exceeds 4. So x is greater than 4. Remember, we talked about exceeds means more than 4. When we go to graph it, I'm going to draw a number line. I'm going to put the 4 there. Exceeds, since it is greater than, it is an open circle, and we shade to the right. This is what you should have. The next question is saying, this part here is saying, is this number a solution? Is 5 a solution to this inequality? Is 5 in the shaded area? Yes, it is. So it is true. Number 8 says x is at least -1. At least, remember, that's going to be that opposite thing. So it's going to be greater than or equal to -1. So I draw a number line. I have -1. It is equal to, so I'm going to draw a colored in circle, greater than, shade to the right. Now, what may help you is trying to figure out where the 0 is on the number line. Like the one before, the 0 is over here. The 0 would be here on a number line. Is -5 in the solution set? -5 would be over here to the left. Is it in the shaded area? No. So this is false. Number 9, x is a maximum of -2. X, if it is a maximum, it's the most you can go to. So it would be less than or equal to -2. So hold on, let's pause a second and let's go over here and put x as a maximum. So x is a maximum right here. Maximum, less than or equal to. All right, right here. There we go. Maximum. So maximum would be less than or equal to. We can add minimum. To greater than or equal to. So make sure you have those two written down. Again, this list will continue to grow so that it will help you as we go through and try and answer some of our test questions. Okay, so my number line, I've got -2, and the 0 is over here to the right of it because it's getting bigger that way. So less than, I'm going to, or equal to, I'm going to shade it in, color it in, and shade to the left. Then it's asking, is -2 a solution? Is -2, it's a colored in circle. If it's colored in circle, that means it is true. It is a solution. All right, the next one says x is a negative number. X, if something is a negative number, it is going to be less than 0. Any number that's less than 0 is going to be a negative number. Is 0 negative? 0 is not positive or negative, so that's why we leave it as less than. So at 0, we're going to have an open circle. Less than means we shade to the left. Now, is 0 a solution? Is it shaded in at 0? No, it is not, so this is false. The next one says x is between -1 and 1. So here's what you do. You take the small number to the left, the x is in the middle, the large number to the right. Anytime you do that, my arrows are always going to point to the left like this. It's going to be the less than symbol. It says x is between -1 and 1. Doesn't say it's equal to, it's just between. So the way we graph this, if we've got two numbers, we've got -1 and we have 1. First off, it doesn't have equal to, so they are open circles. If they are between, we shade in between. So the solutions are anything that is in between -1 and 1. Is 0.5 in there? Yeah, it's somewhere in the shaded area, so this is true. Now the next one is going to talk it's going to make a difference when we graph because of the word integer. All right, let me move my paper up a little bit. Integer, this word integer is going to mean a whole number. It's going to be like 1, 2, 3. It can't be, integer means it can't be any decimal or fraction. It can be positive or negative, but it can't be a decimal or a fraction. So it's going to say x is more than 4. Well, that's fine. But now when we go to graph it, 4, 5, 6, 7. When you are shading, you are making it be every number, every decimal, every fraction in between those two numbers, or bigger or smaller than that number. This is saying integer. It can only be whole numbers. Well, wait a minute. Does it say it's equal to 4? No. What's the next whole number bigger than 4? The next whole number bigger than 4 is 5, then 6, and 7. When they say integer, you have to put dots. That's the difference between continuous and discrete. Integers are discrete data because they are specific points. All those other ones that have the shading are continuous. Now, is 4 a solution? Did it say it was equal to 4? No, so we will write false.